All right, so now we're going to look at number 4, which is calculate the mass percent of carbon, nitrogen, and oxygen in acetamide, which is C2H5NO. So in number 1, we went from percentages to empirical formulas. Now we are going to go from the empirical formula to the percent. So once again, we're looking at number 4. And we want to find the percent of carbon, nitrogen, and oxygen in C2H5NO. That is acetamide right there. So we're going to look at what we're given and we're going to write down what we know. So from this formula, we know that we have 2 moles of carbon, we have 5 moles of hydrogen, we have 1 mole of nitrogen, and we have 1 mole of oxygen. I got all of this just by looking at this formula here because each one of these numbers tells me, remember there's like a little 1 right here. So each one of these numbers tells me how many moles I have of that element. So now that we have this, we want to calculate the mass percent. So we need to convert these to a mass unit, which is grams. So I said convert, which means we're going to set up conversion factors. I know you love these. Okay, so we're wanting to cancel moles and go to grams. So moles is going to go on the bottom because what's on top cancels on the bottom. Moles on the bottom for all of them. And then we are wanting to convert to grams. So grams is going to go on top because that's what we want to get to. Now, the relationship between these two can be found on the periodic table, just like we did in number 1. So we're looking at our atomic mass, or our molar mass. So we need 1 mole of carbon, 1 mole of hydrogen, 1 mole of nitrogen, and 1 mole of oxygen. So 1 mole of carbon, we're going to look at our periodic table, and we see by the molar mass on the bottom, the little that's my son, I apologize. That number right there, that is our atomic mass, and that's what we're going to put on top. So for carbon, it's 12.01. For hydrogen, it's 1.01. For nitrogen, it is 14.01. And for oxygen, it's 16.00. Once again, rounding to the nearest hundredths place. So now that we have all of that, we can cancel out all of our moles. And we are only left with grams. So we're going to multiply across the top and then divide by 1, but you really don't have to divide by 1 because, you know, it's just going to be the same number. Okay. Give me just 1 second. Oh. Okay, so now that we have all of that, we're going to multiply across the top. So 2 times 12.01, that gives us 24.02 grams of carbon. 5 times 1.01, that gives us 5.05 grams of hydrogen. 14.01 grams of nitrogen. And 16.00 grams of oxygen. These two stay the same because you're multiplying them by 1. So now that we have all of this, we have to think about what percentages are. Percentages are shown in pie graphs. So you have something kind of like that. So this is a whole. We have a whole pizza pie, and then each one of these are chunks, and you're going to get the percentage of each chunk that is in this whole. So in order to find percentages, we need what the individual chunk numbers are, and we also need what the entire pizza number is, the total. So in order to get that, we're going to have to add all of these up to find our total mass. And if we do add all of those up, we get 59.08 grams. So now that we have our whole, or our whole pizza, we need to figure out how much of each one of these parts goes into that whole. So, in other words, how much of carbon is going into this whole compound up here. So, we're going to have to divide each one of these by the total. 9.08 59.08. So now that we have that, we're going to figure out those numbers, but we're also going to multiply by 100 because percentages should all equal up to 100, and 100 is the magic number for percentages. So we are going to get a smaller decimal number for this, but whenever we multiply by 100, then we'll get like a real number. So 24.02 divided by 59.08, and that is going to give us 40.66% carbon. And then 5.05 divided by 59.08, and that is going to give us, I'm pulling this from memory, 8.55% hydrogen. Excuse you, Cannon. And then we have, actually, do I have a calculator on this thing? Y'all probably know better than I do. Okay, Cannon's going crazy over here. I have a calculator somewhere, but I don't know where it is. I know there's a calculator on this computer somewhere. And I'm using my phone to record, so give me a second. Hold on. I'm gonna go grab my calculator because I don't want to mess this up. Okay, so see if this works. Okay, good. So 14.01 divided by 59.08, and we're going to multiply that by 100, and that gives us 23.71% nitrogen. 16 divided by 59.08 times 100, and that's going to give us 27.08% oxygen. And if you add all of those up, then that should equal up to 100. So these right here are going to be your final answers. If you want to write it out, you can, but I'm not really requiring it. I see that you got all these. If you want to highlight these, that would be awesome for my eye. So the total compound, so this whole thing right here, consists of 40.66% carbon, 8.55% hydrogen, which I guess is kind of surprising because that's what we have the most moles of. So that's why you can't go off of this. You have to figure this out. You have to work all the way through. And then we have 23.71% of nitrogen and 27.08% of oxygen. And that, all of those are your final answers right there. So sorry for all of the interruptions in this, but I hope that me explaining this again kind of helps you.